Alright, here we are again in our just the maths series in algebra. So this is the second part of our lesson. It's the second part. If you want to watch the first lesson, it's the first part. It's lesson 11. So if you want to check on that, just check on my channel. Okay, so let's get started. So quick review, last lesson we talked about the different laws of indices. So we have our first law. When we multiply any number with the same variable but has different exponent, you're just going to simply add the exponent to get the answer. On our second law, when we divide with the same basis, we're just simply gonna subtract the exponents. On our third law, if we have an exponent inside and we have an exponent outside the parenthesis, you're just simply gonna multiply the exponents. But if you have different bases but they have the same exponent, you can combine them into a single exponent. On the second part of law number 3, on our law number 4, if we have a number raised to -1, that will always be equal to 1 over that number. And if we have a number raised to a negative integer, it will always equal to 1 over a raised to that number on the exponent. Okay, so we have also law 6. Law 6, if we have a number raised to negative infinity, any number that will be always equal to 0. And we have, remember, some more laws that if you have um a base with an exponent of a raised to n, that will equal to the square to the root of a, the nth root of a of the what number. If we have a raised to different a raised to a fraction with different with the numerator, which if the numerator is not 1, then we have that the nth root of a raised to m. So you're just gonna simply switch the numbers. Okay, so now let's talk about radicals. So if you see this symbol, that is what we call a radical, or sometimes it is called surd, but that's a very uncommon word. So we will call that as a radical. So this is used to indicate the principles, positive or principal square root of a number. So let's say when we say a square root, that's like the opposite of the exponent. Like we say 4 times 4, that's equal to 16. But if we have the square root of 16, that will equal to 4. Let's say 5 times 5, that's equal to 25. And what is the square root of 25? So what we got, that's just simply like, it's like the reverse. So the square root of 25 is 5. So the number under the radical is what we call the radicand. Okay. So the principal nth root of a number a is denoted by the nth root of a and is a number x, such as n x raised to the n is equal to a. So if we want to switch some things, so like we have that, so the nth root of a, that will be equal to x. But like what I said earlier, right? Okay, so but if we have the index of the radical, so the index is the n there on that part, the nth root. So what if the n is 2? just what we call the square root. So we usually don't put 2. So you're gonna put just an index on 3, 4, and above on that. Okay, so that's like some quick notes. Okay, so notes, quick notes. So if the index is odd, the radicand may be a positive or a negative answer. It depends, okay? So it can be a positive or a negative, or it can be also both. And if your index is even, that will always be positive, because yeah, so that's just it is, right? So if the index is even, like let's say, I think this is wrong, so let me change this actually. So if I think if the index is odd, the answer can only be positive, right? 1 second, let me check it first for you. Okay, so I guess this is correct. So if the index of the radical is an odd number, then the radicand may be positive or negative. But if the index of the radical is an even number, then the radicand may not be negative, okay? Since no even power of a negative number gives a negative result, okay? So sorry about that. So here's some quick illustrations. Let's say we have the cube root of 64. So that is equal to 4, since 4 cube is 64. But if you have the cube root of negative 64, that will be equal to negative 4, since um, that negative 4 cube is equal to negative 64. There's not an a positive answer to that, because the exponent is odd. If the exponent is odd and the base is negative, it will always, and the answer will be always a negative, okay? So here's the third one. The fourth root of 81, that is equal to 3, since 3 raised to the 4 is 81. And let's say if we have the fifth root of 32, that is equal to 2, because 2 raised to 5 is 32. But if the fifth root of negative 32, that's equal to negative 2. Since what I said earlier, just like on our second example. Okay, let's go to the rules for square roots. A fun topic to work with. So first, if we have a square root of some number raised to square, that's equal to a. So like it will cancel, okay? And if we have um that, we have the square root of a squared, that will be equal to the absolute value of a. And if we have the third rule is this, we have the square root of ab, so you can just simply separate the different the different factors, let's say factors. And the fourth one is if we have the square root of a fraction, we can separate the numerator and the denominator with its square root. So that's just basic rules to we need to remember. All right, so next topic. Let's have illustrations first. So like this, for example, we have this. So this is the third law. Okay, the third law. So let's say we have the square root of 9 times 4. Well, you can just multiply it and get the square root of it, but for the sake of the example of the rule, so we can like separate the 9 and the 4 as we can. see right here, we separate 9 into 4, and the square root of 9 is 3, and the square root of 4 is 2. And if we multiply them, it will give you 6. 3 times 2 is 6. But if we want to this, you can just multiply this first and get this 36. And you can just square root, you can just get the square root of 36, and that will equal to 6. So it doesn't matter, it's just like it depends if but just use what you're comfortable with. Okay, so I have a second illustration. Let's say we have this. So we can first divide 144 by 36, so that will give you 4, and the answer is 2. But if you want to be more smart, let's say, so for the sake of the law, so this is the law that we use, the fourth law. So if we want that, we can separate the numerator and the denominator and get the square root of them. And the square root of 144 is 12, and the square root of 36 is 6. And when we divide this, it will give you 2. Okay, so next topic, we have the rationalization of radical expressions. So it is often desirable to eliminate expressions containing radicals from the denominator of a quotient. So this process is what we call the rationalizing of denominator. So process involves multiplying the numerator and the denominator of the quotient by the same amount, and that amount which eliminates the radicals in the denominator, often using the fact that the square root of a number multiplied by itself gives just the number. So let's have an example. So let's rationalize this. So when we rationalize, so you're just gonna multiply the numerator and the denominator by square root of 3. If you're wondering why square root of 3, because when we multiply square root of 3 by square root of 3, that will equal to 3, right? Because the square root will cancel. But of course, when we multiply something in the denominator, you will also multiply it on the numerator, so that the answer won't change. So I have something to change here also. This should be 4. 4. There we go. 4. So okay, so you're just simply gonna multiply it. So 5 times square root of 3. So you're just gonna combine them since you can't do anything on that. And then square root of 3 times square root of 3. So the square root will cancel, it will give you 3. And if then we're gonna multiply, since we can still simplify, and this will give you this answer, the 5 root 3 over 12. So that's the final answer. So next example, let's rationalize this. 4 over square root 5 plus root 2. So multiplying. So if we have something like this, you're just gonna multiply the numerator and the denominator by its conjugate. So when we say a conjugate, you're just going to multiply it by the same one but with a different sign. With the same expression but with a different sign. This only works on plus and minus. Just take note on that. So here. So you have 4, and you're gonna multiply the numerator and the denominator by the conjugate of this, and then to get the top part, so just simply gonna distribute 4 times square root of 5, that's 4 root 5, since you can really simplify that. 4 times root 2, that will also give you 4 root 2. But here, we're going to use the FOIL method, but I have a secret for you. So if we're gonna multiply an original expression by its conjugate, so you can just simply do this. So you can just simply um, multiply this on this and multiply this on this, and it works to all of the conjugates. So 5 times the square root of 5, that will give you 5, and root 2 times the square root of root 2, since they're the same and they're on radical, so you're just gonna simply gonna cancel the radical. It will give you 2, and then 5 minus 2 is 3. So this is the final answer. Okay, next example. How about this? So if you want to try it on your own, just try it on your own. Just pause the video if you wanted to. Okay, so we're gonna multiply this fraction by its conjugate. So the conjugate of the square root of 3 minus 1, that will give the negative, I mean the 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 opposite of that. Okay, so 1 times root 3 plus 1, anything divided by anything multiplied by 1 is the same as it is. Okay, so we can use our trick. Square root of 3 times square root of 3, that will give you 3. Negative 1 times positive 1, that will give you negative 1. And 3 minus 1, that will give you 2. So, since we can't really simplify this one, that's the final answer. Okay, so last topic. So, changing numbers to and from radical form. So, we have this formula here. If you have a raised to n, oh, so this is the formula on the review. Yeah, so if we want to go to radical form, we can go to the type of the left to the type of the right. So if we want to change the exponential form into radical form, just use this to this. And if we're gonna go to the right to the left, so we can, if we want to go to a radical form into the exponential form, we can move this to this. Okay, so just follow this formula. So quick notes. The word exponent is just another word for power and index. Okay, examples. So let's express the number x raised to 2 over 5 in radical form. So let's have our solution. Let's have our formula. So this is our formula. A raised to m to n. So when we have that, so we have 2 raised to 5. So this now be our n, m, and this is our n. So if we have m, can have this. So m the goes to the exponent inside the radical, so that's why we have 2, and our n is 5, so that will be the index. So this is our final answer. Next, express the cube root of x raised to the 5y raised to the 4 exponential form. That's our solution. So let's have that. So we can move this into radical form. But if we have um double variables, we can just put this on inside and then raise it to 1/3. So we can like use the law that we have in our review here, this law, but it's the opposite one. Okay, so we can use this and we can distribute um the exponents to the outer exponents. So 5 times 1/3, that's 5 over 3, and 4 times 4/3, that should be 4 over 3. Let me fix that. And there we go. Oops. Okay, so that's it for our lesson this evening. So we have got to a long progress in this algebra lesson. So if you have any concern, just leave a comment on this lesson. And so that's it for this lesson, and thank you so much for your attention. I'll see you in the next one next week.